In the last lecture, we have made CLR1 parsing table, and from the table and from the go-to function, we have seen that fourth and seventh state are same. In both the states we have R3 reduction, but only lookup symbol is different. Here it is dollar and here it is A and B. And in the similar way, third and sixth states are also same. And in the similar way, we have 8 and 9 states are also same. 8th and 9th state same production, R2 only the lookup symbol are different. So now we are going to apply minimization algo on CLR1 parser. So how we can apply it, we'll see here. So as I have said, how the states 3, 6, 4, 7 and 8, 9 are differ only by look ahead symbol. So how we can make a table? We can make a table like this. A B dollar S A, as we have made earlier, according to the grammar, that terminal and the variable and the number of states were. So because 3 and 6, 4 and 7, 8 and 9 are merged, rest are same. So start from 0, 0, 1, 2 and 3 with 6. We'll write like this: 3, 6, then 4, 7, then 5, 6 and 7 are complete, then 8 and 9. So like that we will make that table. So how we are going to write it, let's see. See here. So from the table that we have made earlier, so what transition we have? S3 and S4. So because S3 is there, so 6 will also come. So we will write S3 6, and instead of, because 4 and 7 states are same, so we will write 4 and 7. The rest will remain same. This will remain same. So we will write here S3 6 and S4 7, and at the first state except is there, and at 0th state for S transition it is going to first state, and for A transition it is going to the second state. So it will remain same. And at the second state again S3 is there, so we will write S3 6, and at B transition at second state we have S4, so we will write S4 7, and this will remain same because from second state to A transition it will go into the fifth state. So in a similar way we will write all whatever we are having in this table, CL1 table. So wherever we have 6 we will write S3 6, where we have S3 we will write S3 6, wherever we have S4 or S7 we will write S4 7. Like that we will write. So we are writing here in the similar way. We are writing here S4 7, and here 8 and 9 both. Because why 8 and 9? Because 8 and 9 states are same, or we can say simply at third state is 8 transition is going to 8th state, and at 6th state for 8 transition is going to 9. So we are merging them 8 and 9, so we will write 8 and 9 both. So we are writing here 8 and 9. So now at 4 7 R3 reduction is everywhere, so we will write here everywhere. At fifth state only one reduction because first state completed, so R1. And at 8th and 9th state R2 reduction, so we are writing R2 everywhere. Now the thing is that this is a reduction minimization table, but here problem can come when reduce when reduced transition occur, then problem can come. then problem can come, because we can say simply that different reduction can be possible, because if different states are there, then a different reduction possible, so we cannot merge them, because we can merge only states, but production cannot merge. Like here the reduction are same, but if reduction are different, like here R3 and here R4, so we cannot merge them. This is the meaning of that. So yeah, here everything is okay, so no problem. So we are here, we are merging the states. How we are merging the state? We are writing here A B dollar like this. So we are merging all the lookout symbol. So A dot A B dollar. This is the third state. I will show you the third state. This is the third state and this is the sixth state. All things are similar, only the lookout symbol is different, so we are merging them with the lookout symbol. So in the similar way, fourth and seventh and eighth and ninth we are merging. So like that, B comma A oblique B oblique dollar. So this is I3 state. So now our I0 rest, because we are not merging, so we are simply write like this. So in the similar way as we have done in the last lecture, we are doing from I0 to A. From I0 to A we are going to the I3 state. So in the similar way I am writing here. The only thing we are doing is minimization. So the which are not minimized, we are writing only the simple name, state's name, and which are minimizing, we are writing the complete with the transition. So we'll see here. So and for A, and from I0 to S we are going to I1, and I2 we can say simply from I0 to A variable we are going to I2, and from I2 to A terminal we are going to I3, and from I3 to B terminal we are going to I4. So A tends to B dot comma A oblique B oblique dollar. So this is I4th state. This is I4th state, and this is, we can say simply I47, and this is, we can say simply I36, because we are merging these two states. So it will return to its only when iteration occur. And till now what is left? I0, I1, I2, I3, I4. Now we will see for I5. So from this A, B, this, and from I2 to when the A terminal, sorry, A variable, then it will go to I5 state, and from I0 to B transition, from I0 to B transition is going to I4. So I1, I2, these transition are over, like that it is over, and from I2 to B transition it is also going to I4. Fine. So now what is left? 8 and 9th state is left. So when from I3 to we are moving towards I8 and 9 with A variable, so A tends to AA dot comma A oblique B oblique dollar. So we will reach to A8, I8, or we can say simply I8 9. So we can say how many states now? 1, 2, 3, 4, 5, 6, 7. Only 7 states. Number of states are 7. And initially it was 9, or we can say 10 because start from 0. Now number of states are 7, so 3 states are reduced. So we can say simply LR0, sorry, not like this, in respect of number of state, N1 is equal to N2 is equal to N3, or we can say N4, and less than equal to N3. This is the general formula, and what they are, this is LR0, and this is SLR1, and this is CLR, and this is LR1. And the number of state here will mean 7. LR0 and SLR1, it will mean 7. CLR1, or we can say N3, it will be 10. And when we are applying minimization, as we have applied here, so it will convert into the LR1, and the number of states, or we can say N1, N4 will be 7. So like that it will 1 LR0, SLR1, LR1 all will remain same. When CLR1, it will be more, because according to the required symbol, as we have seen in this example, it will work. But if we want to reduce them and without any transition problem, then we can reduce it into the LR1. Then the number of state will be remain same. So this is all about how we can minimize a CLR1 parser when there is no conflict in the transition.